Alright, welcome to the video on Graphical Behavior 1, and this is day 1, and today we're going to focus on increasing and decreasing behavior of a graph. And we've done this before where we've explained where a graph is increasing by looking at the graph, or where the graph is decreasing by looking at the graph. But today we're going to approach it analytically through the use of calculus. And in this video I'm going to cover day 1 and one of the examples from day 3 just to shorten the next video, or sorry, one of the examples from day 2. Alright, let's get to it. Today's objective is to find the increasing and decreasing intervals from a graph or an equation. And we learned how to do it from a graph back in pre-calculus, so primarily in calculus we're going to learn how to do it from a function. As a quick refresher, increasing functions are ones that tend to move uphill as we move from left to right. Decreasing are the ones that go downhill from left to right. And then the only other option is that it's constant, which means it's flat as we move left to right. And the hallmark, the calculus aspect of this, is that increasing functions have a positive derivative because the slope is positive, and decreasing functions have a negative derivative because it's decreasing, it's negative. So let's take a look at this function real quick here. From a graph, we should be able to see that the curve is increasing on this interval, so from -3 to 1. And we always describe increasing, decreasing behavior with open intervals. The function is decreasing from 3 to 5, and finally the function is constant from 1 to 3. So there we go, all of them are open intervals. We sometimes throw out this word monotonic, which means the function is always increasing, or always decreasing, or always constant. So as long as the behavior doesn't change, then it's said to be monotonic. Even if the slope might change a little bit, this curve is always increasing. Okay, let's take a look at example 2. So the important idea is that on a continuous function, the derivative can only change signs at the critical value. And remember, critical values occur where f prime is equal to 0 or where f prime does not exist. So again, we're going to be seeking out those values to help us determine when f prime changes sign. And we will also look at discontinuities because f prime can change sign at either a critical value or a discontinuity. So without further ado, example 2. Find the open intervals on which f of x is increasing and or decreasing. So first off, the function is continuous, so there are no discontinuities, so we just need to find our critical values. So that's the first step that we're going to take. F prime of x is equal to, we take the derivative and we get 3x squared minus 3x. And we can factor that because that allows us to find the critical values more easily. When we set this equal to 0, we find that there are critical values at x equals 0 and x equals 1. From here, what we do is we're going to set up a number line to help us determine the behavior of the graph. And we're going to label all discontinuities and critical values on that number line. So in this case, we just have two critical values of 0 and 1. And what we want to do is test the sign of f prime. So if I use a value that is less than 0, we'll say like -5, and I stick that into my f prime function, I'm going to get -15 times -6, giving me a positive answer. So that interval f prime is positive. Then we take a number between 0 and 1, like 1/2, and we get positive times a negative, so this is a negative. And finally, we take a number greater than 1. So if we plug 2 in, we'll get 6 times 1, or positive times positive, and we get positive. And what we see here is that our function is going to be increasing, then decreasing, then increasing. And I encourage you to draw these in here because it kind of starts to sketch roughly what the curve might look like. You might get a curve that kind of comes up to a maximum, comes down to a minimum, and then continues onward like that. So it's a rough sketch of the curve. Anyways, we can conclude that we have increasing behavior from negative infinity to 0 and 1 to infinity. And we have decreasing behavior from 0 to 1. So we should always be trying to answer in a complete sentence and justifying our answer. So let's go about doing that. We'll say f of x is increasing on negative infinity to 0 in union with 1 to infinity because f prime of x is greater than 0. So our derivative is positive, so the function is increasing. Then we can say that our function is decreasing. F of x is decreasing on 0 to 1, always writing open intervals, because f prime of x is negative. All right. So as a recap, what we did is we established the function was continuous, and then we found the critical values, made a number line chart, tested the sign of the derivative within each portion of the number line chart, drew our conclusion, and then wrote our concluding statements with justification. And this is key for being successful on an AP test, is they're always hitting on the justify how you know. So, okay, example 2b, very similar. We've got a function here, and we need to find where the function is increasing or decreasing. I'm going to go ahead and write this upper piece as a standard form. 4x plus 4 minus 3 is plus 1. Okay, that'll make it easier to take the derivative. No chain rule needed. And again, we want to check to see that the function is continuous, and we discover that at 1 we have a discontinuity. So it's discontinuous here at x equals 1, because if we plug 1 into the top function, we're going to get 6, and if we plug 1 into the bottom function, we get 5, so there's a discontinuity there, a jump discontinuity. Also, we want to find critical values, so f prime of x is equal to 2x plus 4 and a to the x ln of a plus 3. There's our derivative, and looking at our derivative we see that we have a critical value at -2. So critical value at -2, and our bottom function, this will never equal 0 because this is always positive, this is always positive, this is always positive. So our bottom function has no critical values, but we do have the discontinuity at 1. So we'll also list that in here, the discontinuity at x equals 1. So when we draw our number line, we have two spots that we want to consider. We want to consider -2, and we want to consider 1. And now we test f prime. So if we take a value less than -2, and we'll say plug -3 into this, we see that our derivative is negative. So it's decreasing there. Then we test a value in here, we'll plug 0 in, and 0 gives us a positive answer. So this is positive or increasing. And then finally we test a number greater than 1, like 3. If we stick 3 into this piece, we're going to get a positive answer. So keep in mind you want to plug into the right piece when you've got piecewise functions. And this highlights an important point. The function doesn't always switch from positive to negative to positive to negative to positive to negative. Here we've got decreasing, increasing, and increasing. So, and this kind of fits with, if we think about how this graph looks, it looks something to the effect of, I don't know, maybe something kind of like that. Anyway, let's draw our conclusion. F of x is decreasing on -infinity to -2 because f prime of x is less than 0. And then finally, f of x is increasing on -2 to 1 and 1 to infinity because our function is positive. So, and we want to keep these two separate because at 1 our function is jumping there, so you can't say that it's increasing or decreasing. Alright, I'm going to cover a little bit of day 2 in this video, just because day 2 is a little bit longer. So let's jump to Graphical Behavior 1, day 2. We'll just do one example.
Today I'm going to light my pants on fire.
You think me confident? All me have to do is send for the new gun. Anything test dead. We just fly off dozen head. Down the mercy.
Kill them.
Duck a dill dill dill. Sell a boy get killed. Duck a dill dill dill. You better sign on the will. Duck a dill dill dill. A boy get killed. Duck a dill dill dill. Look up in the barrel. Limb by limb we a go cut them down. Send for the oxa. Take out the tongue. Limb by limb we a go cut them down. Send for the oxa. Take out them tongue. When them see me see the hit man a come. See me say me just can't done. See me see the hit man a come. See me say me just can't done. Them one tie.
Alright, day 2 is focusing on using this behavior of increasing and decreasing to find relative max and mins. And I'll get into it in more detail tomorrow or in the next video, but first part of example 3 is just finding increasing and decreasing behavior. So I want to do that to practice what I covered in day 1. So go ahead and skip to the next page. And we want to find the open intervals for which the function is increasing or decreasing. So in this case, we see it's a polynomial, so the function is continuous everywhere. So we're just going to jump into finding the derivative. F prime of x is equal to 2x to the 4th minus 7x to the 3rd minus 4x squared. And if we go about trying to find our critical values, we can factor an x squared out, and from there we can even factor it a bit further, and this allows us to use the zero product property and identify 3 critical values. We have one at 0, one at -1/2, and one at 4. So from there we'll do our number line test. We list our 3 values, -1/2, 0, and 4. And then we're going to test f prime. So we plug in, we'll say -1, and we get positive, negative, negative, so that gives us a positive answer. And continuing on down the line, we fill this all out, and we get our our 4 intervals of increasing and decreasing behavior. And then we draw our conclusion. F is increasing on negative infinity to negative 1/2 and 4 to infinity, because f of x is greater than 0. And then f is decreasing on negative 1/2 to 0 and 0 to 4, because f of x, f prime of x, is less than 0. I missed that prime up here. F prime of x. Alright, so there you have it, our increasing and decreasing behavior. If we were to think about what that might look like, we've got a curve that's increasing and then decreasing, and then it's decreasing again until it's increasing. So we probably have something that does that, where you've got the increasing behavior, then it decreases and decreases again before it starts increasing. So we should probably wind up finding that we have one maximum and one minimum, and that's what the next video will be. Alright, thanks for watching this video on Graphical Behavior I. At the end of this video you should be able to find increasing and decreasing behavior of a graph from the equation.